We are going to discuss about depth limited search. Depth limited search is a modified version of depth first search. Depth limited search addresses the limitations of depth first search. Depth limited search, it introduces a cutoff depth beyond which the search stops. It will prevent the algorithm from getting stuck in an infinite loop. This technique is very useful when searching through large complex problem spaces. Depth limited search is similar to depth first search with an addition of a predetermined limit. This limit helps to overcome the limitations of the infinite path in the depth first search. In DLS, the node at the depth limit will be treated as it's a leaf node. The DLS algorithm is terminated in any of the three cases. First, if the problem doesn't have solution. Second, if the problem doesn't have any solution within a given depth limit. This is known as cutoff failure. Third, when the solution is found. Example of depth limited search. Here we have a tree with 4 levels from level 0 to level 3. So level 0 it contains only source node S, and level 1 it has 2 nodes, that is the A and B. Level 2 it contains C, D, I, J. Level 3 it contains E, F, G, H. Depth limit is set to 2. So searching it starts from the source node S and then traverse A and then traverse C. C will be considered as the leaf node. So we have to backtrack and visit the node D. D will be considered as the leaf node. So once again we have to backtrack and visit the node B and then traverse the node I. I is treated as the leaf node. So we have to backtrack and visit the node J. So it reaches the goal state that this algorithm is complete. Here level is limited to 2, then the search technique will not go to level 3. Therefore nodes E, F, G, H will not be traversed. So DLS algorithm is complete if the solution is present within the specified depth limit. Advantages: it's a memory efficient algorithm as it consumes less space. The algorithm it takes less time to execute. It terminates in finite time. Disadvantages: it's an incomplete algorithm as we may not able to get the solution every time when we are going to do the search technique. Second one is if the multiple solutions of a problem exist, then DLS may not able to find the optimal solution. In other words, the algorithm is not optimal. Depth limited search algorithm start at the initial state, explore the search tree, expanding nodes until the cutoff depth is reached. If the goal is found, return the solution, otherwise backtrack. Cutoff depth, the maximum depth the search will explore before stopping. Completeness, depth limited search is incomplete as it may miss solutions beyond the cutoff depth. Trade-off, increasing the cutoff depth improves the chance of finding a solution but requires more time and memory. Advantages of depth limited search: avoids infinite loops. The cutoff depth prevents the algorithm from getting trapped in an infinite loop. Reduces memory usage. Depth limited search only stores the current path, not the entire search tree. Finds shallow solutions. The algorithm is more likely to find solutions closer to the initial state. Customizable depth. The cutoff depth can be adjusted to balance completeness and efficiency. Disadvantages of depth limited search: depth limited search may miss solutions beyond the cutoff depth. Time complexity. The runtime can be exponential in the cutoff depth. Space complexity. The algorithm still requires storing the current path. Cutoff depth. Choosing the right cutoff depth can be challenging. Applications of depth limited search. So it's used in many applications. Game artificial intelligence. Depth limited search is used in game AI to explore game state spaces and find the optimal moves. Path findings. It can be used to find the shortest path in many environments with the cutoff depth limited search. Problem solving. Depth limited searches are applied to various problem solving tasks such as scheduling and resource allocation, logical reasoning. The algorithm can be used to explore logical inferences and prove or disprove the hypothesis. Thank you.